Alright. Okay, so a couple things that I do want to make sure that I'm clear about. Just so that when we start off, because I know that now that we've had 2 exams, people are starting to ask questions. So I wanted to say this in all the class prayers just so that we're all kind of clear as moving forward. So now that you guys have had 2 tests, some of you guys are doing fine. Others of you guys would like to do better, or are worried that it might all of a sudden become a situation where you're not doing so well in the class. And so I just want to be clear that when it comes to practicing, okay, I know nobody reads my syllabus until you have no choice but to read it because you need to know something, like how much the final exam is worth. Then you go to the syllabus, you start searching to try to figure it out, right? But in my syllabus, it tells you guys the textbook that I'm using for the class. Okay, it shows you the OpenStax book. If you want extra practice, you can pull up OpenStax and you can take a look. And I don't assign all the questions, so all the odd numbered questions have answers to them, and you can do those questions if you want it. If you want additional practice, the other thing that you can do is you can Google search limits and continuity, multiple choice practice with answers, and stuff would come up with the answers. Same thing with all your derivative stuff. That's why I give you guys like the topic heading for every single section in the calendar. So that way, if you ever wanted to Google search anything, you would Google search by the topic. Okay. And I think that that's very, convenient and helpful for you guys. The other thing too is that in my syllabus, there's 2 practice textbooks that I put in there. And those are the top 2. There's other ones available as well. But I will tell you guys, I would say for 90 to 95% of the classes that you guys take, if you were to buy a Barron's study guide for any AP class, more than likely, you could self-study the class without the teacher. Like, seriously. And for all you guys that have AP, you understand because you bought the Barron's guide because you're like, I don't know what's going on. If you buy the Barron's guide, you really can use it to self-study just about any class. And I say that because I helped somebody learn history, or was trying to help somebody study history this summer. And what did I do? I went to Barron's. I bought World History, APUSH, and Gov. All the AP study guides, all 3 of them. And I was like, and here's history from 1200 to present. Around the world, and also the United States. And it is a very comprehensive book. If you were to take all of those pieces, you could study history from 1200s to present. So, I will say that if you were to get Barron's, and Barron's is structured this way, like I think for every single AP class that I've looked at, they structure it almost the exact same way. They go topic by topic, all the way through to help you to prepare for the AP test. So if you were to want more practice related to calc, they do have multiple choice questions, and it is, probably your best way of getting more multiple choice questions with all the answers too. You don't have to get the 2022 version of it. You can easily get a 2018 version. I always say this too, you can always get a used copy because you don't even know what somebody wrote in there was right to begin with. So really, all you really want are the practice questions, more than anything, if you want additional practice. Now, I will have you guys sign up for AP Classroom sometime this week. I will push out the code, but I will tell you guys something. I do not assign anything in AP Classroom. Nothing. The reason why I do that is because everything that you've seen is already in AP Classroom. So when I first started teaching calc, AP Classroom did not exist. I wish it had. It would have saved me hours and hours and I did instead is I got all the released questions from 1969 until present. I separated them by unit, literally cutting them apart, cutting question by question apart. Mr. Bird thinks I'm crazy. I kind of am. But I cut them top by topic. Then within each topic, I sub-separated them into other topics and put them all together, and that is your curriculum. So you essentially, all the practice questions that you guys see are all on Classroom. So there's no point in me assigning you anything in Classroom because you're already seeing it. And in that sense, I don't want the technology to get in the way of the learning. And I think in a lot of ways when you do that with math and you assign something like that digitally, you can run the risk of technology getting in the way. Okay, so that's why I will not assign anything out of Classroom, is because you guys get all those questions anyways. Okay, as far as studying for a quiz or a test, again, do the review before you take the quiz, do your quiz corrections before you take the test. I don't think it's a good idea for you guys to have your review and your quiz corrections to do the night of the test, because I don't think you'll get through all of them. It is to your benefit to use the review to study for the quiz, then use your quiz corrections to study for the test. Okay, so that's study and preparation or practice problems if you want it. If you still have trouble finding stuff, you can ask me and I can help you guys find additional practice questions. But for the most part, you're going to be just as good at Googling something as I would. Okay. The other thing, too, I would say is you can always get with a group of friends and everybody buys a different study resource. Because then you have more practice questions if you did it that way. You know, so I'm trying to think if there's anything else related to that. Oh, somebody asked me how I structure the quiz and the test. Because that's always a question that, you know, like, how do you do it? I have a method for everything that I do. When it comes to your review, your quiz, and your test, this is what I do. I know this sounds ridiculous. I take all the questions I could possibly ask you. I separate them out by topic. What I think by topic. And then I'm like, oh, review, quiz, test. Review, quiz, test. Like, literally, that's what I do. And then I take all the review questions and I retype them. Then I take all the quiz questions and I retype them. All the exam questions and retype them. And then I look to see whether or not I have too many tricks in any one category. Because if I'm going to have more tricks somewhere, I'm going to put that on the review. But seriously, like, I know that sounds totally ridiculous. Mr. Bird can say this is actually what I do, because he actually saw me with a paper cutter, cutting questions, and then stapling them and retyping them to make your quizzes, your tests, and your review assignments. And then when we got Edulastic, I took all the stuff that I had in Google Forms and I retyped them in Edulastic. So I have 600 questions somewhere in Edulastic. Well, because of COVID. That was the only, I couldn't use Google Forms. I didn't want to use Google Forms to run quizzes and tests. So I used Edulastic so I could see progress as people were taking it at home. Why? Because I'm slightly crazy.
Yeah.
Yes, Ben?
Still have like the hard copies of all the questions you cut out?
No, because once I retyped them, there was no reason to have them anymore, so I threw them all away. Shredded them all.
Sounds like he's looking for the track video.
Oh, I did this years ago. So I have all of my questions that I have in paper copy. They're all digital now.
Also, then again, if you did that, you'd just be studying the questions and getting the answers.
Yeah. I mean, and in the end, so that's another thing too. Somebody will ask me, because they'll be like, oh my gosh, I think I cheated. And I'm like, how'd you cheat? And they go, well, I was Googling practice questions, and I happened to see the one that you tested on. Well, I mean, that could possibly happen. I mean, it could. I know,
The
I
one
know.
time Hannah drew a.
Well, I know, right? That happened with
It
you
was
guys.
fun. We asked like an example, like as a system example. She's like, "That's on the test."
Yeah. I mean, you guys will get really good, especially this particular class. You guys will get really good at practicing and asking questions, and you might feel weird that you've asked a question that actually shows up on a test or a quiz. So I just don't want you guys to be concerned about that, because I feel like you guys would be. Especially like I know that last year, Ethan, wasn't it Bilal that had pulled a practice question and then showed you guys, and then happened to be the one that happened to actually be almost word for word the one that was on the test.
Yeah, it was so funny because every time me and him and Muhammad studied together, he always got like the exact questions that were on the test. We always just worked.
And that's the thing. Sometimes sometimes you will over prepare, and because you over prepare, you will see something that I will put on the test. It could happen. And if it was going to happen, it would happen, I think, with you guys, or influence from you guys, where that would happen. Because like Bilal was in BC, and so he would pull tons of questions and look at them. Yeah, and you guys were using BC questions. So, I mean, I'm just saying, like, I don't want you to be weirded out if by some chance you overstudy, and then you're like, oh my god, I studied something that was on the test.
When you're at least all like the practice at RQs again.
Probably not till the spring. Okay, so now we have to do actual stuff, actual calc. Remember, I told you guys on Friday. I told you guys on Friday this was going to be a later problem. Well, it's a problem now.
Yeah.
So
Tomorrow problems. Yeah.
go ahead and open up your 2-1. I don't want to talk over you. I'm attempting to not lose my voice in the first few weeks of school. Normally every year, just like this Beaver team lost her voice, I lose my voice every day. Which I almost did when we were scooping ice cream on Friday. So they were like, you have a bigger voice. I do. Typically I do have a bigger voice. Okay, so in your 2-1, first thing, and that is, I will say this numerous times because the first time you tend to read directions happens twice. It happens at the beginning of the school year because you're super worried about a brand new class. And then it happens the day of your AP test. And everywhere in between, you typically don't read the directions. So I will try to make sure that you guys are aware of vocabulary, because College Board is really good about throwing in words that you're like, I don't know what that is. Okay. And one of the words they typically throw in is the idea of what a secant line is. A secant line is just a line that connects 2 points together. That's it. But they'll throw in the word secant line on the actual AP test, and you'll be like, what's a secant line? I only heard of a tangent line. Normally, you could probably guess your way through what a secant line is, but I don't want you guys to be so confused that you can't guess your way through it. So essentially, a secant line is just a line that connects 2 points together. You have a tangent line, and a tangent line from geometry related to circles. A tangent line forms a 90-degree angle with the radius of the circle. If I connect infinitely many tangent lines together, I form the entire circle. If I was bored. No. I barely have time. I actually have like 5 chapters I have to read before final font tonight.
You're procrastinating like us?
No, I totally forgot.
Oh.
I got the email of, hey, you're supposed to have done this by tonight. And I said, oh. And then I was like, where are those books? It's so bad.
Welcome to our world, Mrs. Hayden.
It was so bad. I'm like, whoops. I'm like, I need to get it together. Okay. Just like circles with tangent lines, I can have a tangent line to a curve, and technically it is perpendicular to something, but we will talk about what it's perpendicular to later. It has to deal with vectors.
Velocity.
You actually go from one direction to an AB.
Because it's orthogonal. Okay, so because we have tangent lines, that means that we can have slopes of those lines. That also means that we can have equations of those lines. The slope of any tangent line at any value of A looks awful familiar.
I don't recognize this. Wait.
Okay, so what you notice is that it looks very familiar to what you did in 2-1. All I've done is I replaced all of your x's by a's. So I can find the slope of any tangent line at any value of a, which is a value of x, by using the limit definition. Now, we do a very good job about brainwashing you. That you think that every single equation of every single line should be of the form slope-intercept. Slope-intercept requires effort. When you have to put forth more effort, that means that you can make more errors. It is 1,000 times easier to take any coordinate point and any slope and write it in point-slope form instead of slope-intercept form. Because all you're doing with point-slope form is plugging it in. You're not plugging in the point, then solving for b, then replugging it back in. Essentially, all you're doing is you're going to take your slope, plug in the coordinate point, call it a day. So anytime I ask you to write the equation of a tangent line, unless it is a multiple guess situation and all your answers are in slope-intercept form, don't do it. Leave everything in point-slope form. Well, we'll do that as we get closer to tangent lines and stuff. Okay. Now, moving to 2-2.
Power rule. Algebra.
Every single time you turn a page, that you have to like go into conversation. Okay, so you have done a lot of mathematical operations in your life. Addition, subtraction, multiplication, division. Those are rules. Those are operations. You have also extended those operations to doing distributive property. Distributive property is an operation that you do. When you do distributive property, you multiply and distribute all the way through. There's a rule by which you do it. There's a process. Finding what's called a derivative is a operation. Very similar to distributive property. It's a rule that you do every single time. Now, when it comes to derivatives, First of all, calculus's purpose in life is to explain physics. That's literally its only purpose in life. Now, the purpose of the derivative is to take a position equation, or your position equation is typically how you would find displacement, the change in position. That equation, when you do the derivative of that equation, it takes you to velocity. Instantaneous velocity, meaning the velocity at a specific value of time, like t is equal to 3 seconds. When you take the derivative of velocity, it gives you an equation that represents acceleration of that same object at any value of time. So the idea of you taking derivatives and doing that operation takes you from position equation to modeling a velocity equation to then modeling an acceleration equation. That is its purpose in life. Now, to take a derivative requires knowledge. There's taking a derivative when you have polynomials. There's taking a derivative when you have trig and exponentials and logs. That will be tomorrow's problem. Then you have issues when you have a product or a quotient, because there's rules for doing those. There's rules for doing those when they're polynomials. There's rules for doing those when they are logarithms or exponentials. Okay, or trig. Then there's chain rule. Everybody that hasn't seen it before goes, oh, great. But, so there's all these rules, and really, you're learning all these rules for one main goal. Take position to velocity and velocity to acceleration. That's the only purpose. For any type of equation that we can find to model position. It could be a sine curve, it could be a logarithmic function, it could be an exponential. Whatever it may be, we have to do the derivative to take us to velocity, to take us to acceleration. That's its purpose in life. The operation itself, when I tell you to use power rule, you have no problems doing power rule. When I tell you to use product rule, you have no problems doing product rule. You know what the problem is? Jumble them all together. Because then you have no idea what to do and which process to use. That is the hardest part about this unit. When to use which process. So when you go and try to study for any quiz or any test, if you were to Google search derivatives practice, the one thing you should practice is, do I know which process to use? That is the absolute hardest thing in this unit. Which process to use? How you can look at a problem and recognize immediately what you're supposed to do. Because if you have to think too long about which process to use, you won't finish the quiz or the test. Okay, so that is literally where you're going to make your mistakes. It's not going to be, typically it won't be within the actual calculus part. You might have a problem with arithmetic.
The algebra along with it too.
You're going to start to see some pretty bad arithmetic stuff that you'll do, and you'll be really frustrated. So I'm warning you, because it will happen this unit, and if it doesn't happen this unit, it will definitely happen next unit. Just so that we are clear, this unit is the quiz and the test and the review all multiple choice, not any free response. Free response is the next unit.
Oh. What's the next? What is the next one?
You will find out. Okay. So the derivative is defined by a limit. Oh my god.
Oh my god.
Oh.
Wow. Looks like this is the last time we see that one.
No, you'll see it in 2-13 also.
But it seems to be used the short way that time.
Okay. This is your limit definition of a derivative. Looks awful familiar. Okay, so let's think about this. First of all, and it's funny because I said this in the last class period, and then they're like, "What is your problem?" I'm like, "I don't know." Okay. So here's your limit definition that you did in 2-1. This is f prime of x. So this notation, the apostrophe, not a -1 because that means inverse. The little apostrophe makes it the derivative. Okay? You can do this with a y equals equation, that would be y prime. I said prime like as in prime rib. Because I couldn't think of another way to say prime in 0 period, and then somebody in first period goes, "You could have used the math one, like prime number." Oh yeah! You didn't think about that one. You're gonna find I make a lot of food references. So if you weren't hungry when you started this class, you'll be hungry by the end. I'm like, oh yeah, I didn't think about that one. I literally couldn't think of another way to say prime in 0 period this morning though. Okay. Alright. So this notation here is for the derivative. Okay. Now, what that means is that means that everything that you guys did in 2-1, you were finding the derivative. You just didn't know it. So let's think about this for a second. We found the limit definition of 5. Remember that nobody knew what I was talking about? Right? We found it, and you're like, oh my gosh, why is it 0? But think about this for a second. If I find the derivative, if my position is constant, my velocity would then be 0. If I had a straight line and I took the derivative, right? Because we had that 5x plus 4, 5x minus 4 question that was in there. That derivative gave me 5. So if I have a position equation that looks like y equals mx plus b, and I get my velocity to be 5 without any variables, what that's saying is I have constant velocity for any value of time. That also means my acceleration is 0. So that's how we're doing things. So everything you guys did in 2-1, all your equations were like position equations. By you finding the limit, you were finding the derivative, and that was giving you your velocity. In a lot of ways, what you do is you end up, anytime you take a derivative, you are linearizing the function, which we'll talk about later. 2, 6, maybe? Okay. And I don't think I did this one. I think I just told you what the answer was. But if I were to find the derivative using the limit definition, I would plug in x plus h squared minus x squared all over h. So x squared plus 2xh plus h squared minus x squared all divided by h. So 2xh plus h squared over h. Everybody has an h. So I get 2x plus h. Plug in 0 in for my h, and I get 2x. A very long book. Okay, so in this section, all you're going to deal with are polynomials. That's it. no trig, no logarithm. That's a tomorrow problem. Okay.
The table.
When you have polynomials, you use what's called the power rule. It is an operation. If your f of x is x to some number, any real number, then the derivative brings the exponent down to the front and subtracts by 1. Subtracts by 1 every single time. Every time. Subtract by 1. It is only good for polynomials. So don't try to do anything weird with trig. Trig is special. You'll find out tomorrow. Actually, you already did sine and cosine. You just didn't know it. You did the derivative already for sine and cosine.
Yes. It's the opposite. Those are the basic ones.
I know.
Yeah.
Well, and we'll memorize the trig ones, and then I'll show you. No, then I'll show you how to actually prove them every single time. I know. I do a little bit more proving in BC.
I asked you to prove something.
Okay. So, how I could have used this for that previous problem is my f of x was equal to x squared. So then f prime of x is 2x to the 2 minus 1, which is just 2x. I'm telling all my AV people and the sophists, do not use product rule today. No using product rule. You do not have product rule yet. I look at the sophomores because you're going to Google something.
Oh,
yeah.
The camera's trying to hide back there. Alright. I know my sophomores are already starting on their homework.
No, we're just finishing examples right now.
I just exposed all of you. Okay. Okay. But I know my sophomores are going to care about this, and then all of you guys, the rest of you guys are still going to care about it too. How much work do you need to show? None.
Let's go.
Okay, but here's the thing. Don't screw it up. So if not showing work means you're going to get the wrong answer, then don't do it. Like, I mean, I want you to get the right answer every single time. So it's just like factoring. Show as much work as you need to so that you can still get the right answer. Don't try to shortcut it and then get the wrong answer. That's really dumb. Like, I mean, I'm just saying. But here's back to the one that you don't like, right? And I do want to say something because I think it was this class. Some of you guys, I think somebody asked me about this particular question with the limit definition, so I wanted to be clear about it. So here, technically, any constant is being multiplied by x to the 0 power. Anything to the 0 power is 1. So when I take this derivative, y prime is 5, 0 to the 0 minus 1 power. And everything multiplied by 0 is 0. Now, somebody had asked, and I think it was this class period, somebody had asked about when we did this one. Technically, this is also 5x to the 0 power. When I do the limit definition of this, I get 5x plus h to the 0 power minus 5x to the 0 power all over h. Everything to the 0 power is 1. So that's why I ended up with 5 minus 5 over h, which is 0. Because all of my x plus h's to the 0 power, my x to the 0 power, all of those are 1. Doesn't matter what's to the 0 power. Everything is always 1. So that's why that one turns into 5 minus 5. Somebody had asked me to prove it, so I just wanted to make sure that we were clear.
Was it except,
Yes.
we leave it in like negative.
Yes. So here, bring down your 5, x to the 5 minus 1, so 5x to the 4. Now, you're going to ask me about showing work. Again, I don't need this. But if it helps you for right now to write out to the minus 1 power so you don't mess up, then write it out. It's fine. But I don't necessarily need it. The other thing too is when you guys are uploading your grade scopes, if you're using the Gradescope app to upload and you mass upload everything, please make sure you're at least selecting one picture to be for every single spot. If you have more than one picture, I'll know because I'll only see one question there and I'll look at the rest of your questions, but at least select one. So that way as I'm going through, I can at least see that you guys have everything that's there. Otherwise it shows up weird, then I have to pull up everything weird. And it's just weird.
Yeah, what is it?
Some people did. Yeah, so if you go through the website, it prompts you to upload one picture per page. Some people have downloaded the Gradescope app, and when you download the Gradescope app, it allows you to upload all your pictures at once, and then take each picture individually and select where it goes. You have to select where it goes, otherwise it shows up weird in my thing. No. I'm not doing product rule today. I'm not doing product rule till Wednesday.
No, but it's how do you count it?
Multiply. FOIL.
Oh.
Are you on question 7 already?
No.
See, that's right now.
Alright.
Oh, question 7. Wait, we're not allowed to do that?
Any roots you're going to change to fractional exponents.
Okay.
So g prime of x, 1/3 x to the 1/3 minus 1. So 1/3 x to the negative 2/3 power.
1, 3, root of x squared.
Like celebrate after every single freaking question.
I know.
We're like the class last year that
We're children
with
with
freshmen next door that always keep clapping for some reason.
Like, holy cow. Your like 10-minute lesson is taking 40 minutes because you guys clap after every single thing. You're like, and then it takes me like 2 minutes to settle you back down to do the next example. Alright. Now, as far as work is concerned, this is me personally. Because arithmetic will start to get really hard. So, I typically, if I'm going to show any work, I don't want to lose anybody at all. Is I would just write very little, just so that I don't accidentally do 4 to the 3rd power. Because sometimes my eyes play tricks on me, and I would hate to do 4 to the 3rd power instead of 4 times 3. I actually do that a lot. Or I'll do 3 cubed instead of 3 times 3 when I do derivatives. So typically, if I'm going to write anything out, I would write out that very first step and do the subtraction of 1 in my head. And then obviously any constants go to 0. Even.
When you do the derivative of a negative, you don't make it into a fraction first.
No. No, I would never turn it into a fraction because I would never want to use quotient rule for it. And if anybody was confused, my in-between step has all my subtraction of 1s. 2x to the 2 minus 1 plus 5 negative x to the negative 1 minus 1 plus 6 0 x to the 0 minus 1. Okay. That's the in-between step I didn't show. Questions? So, again, back to Ethan's question, I would change this to a negative exponent. And then do my derivative. Once you learn quotient rule, after you see quotient rule, you'll never want to do quotient rule for something like this because it takes forever. So 2x minus 3x to the negative 4th power.
And then also something like number 7, where it's in the book.
When you guys see in your homework, this will be important because otherwise you get wrong answers. When you look at question 7, question 8, when you start looking at those that are being multiplied together, distribute or FOIL and multiply stuff out doing the box before you do the derivative. Or if everything is being divided by something, like there's one where everything's being divided by 3, separate it into 3 spots and divide everybody by 3, or divide everybody by x squared, and then do the derivative afterwards. Okay, so turn it into a polynomial-ish before you do anything. Questions? All right, you guys got 10 minutes.
I'm almost done.